and good day, Algebra. We are on to our third and final method. I think the most fun method to solve a system of equations. You'll notice that this is a PO. On the test, you'll have objectives for 40, 41, and 42. All of them will be solving systems. 40 will be designed for you to graph them. Then we graph them and we look for where they intersect. 41 will be designed for substitution. However, you can use elimination for all of them, okay? And so if there's one method that you should know going into the test, elimination is probably the one to know, which is why it is the power objective. And we're going to skip the example here and actually go down to this bottom section, the first Mr. Heavy Pencil question here, because I think that this describes really what's going on the best of all, okay? Here's our system, 6x plus 5y equals 22, and 6x plus 4y equals 20. Why is this not going to be such a great system to solve by graphing? Looking for where those lines are going to intersect on the coordinate plane. Jack?
They have the same slope.
They aren't going to have the same slope. It'll be close, but it's not going to be quite the same slope. So in order to graph an equation, what form do we like the equation to be in? Slope-intercept form. Don't do this on your page because I'm going to erase the work immediately after this. But if I were to put this first equation into slope-intercept form, I'd have to move my 6x over. So I have 5y equals negative 6x plus 22. And then I'm going to have to divide by 5. And that's going to give me y equals negative 6/5 x plus 22/5. How fun is that going to be to graph? Particularly plotting a y-intercept of 22/5. And then using our slope correctly and accurately to get multiple points. Not very fun at all, okay? So the reason why graphing wouldn't be recommended for this is because it's going to be tough to do accurately, right? Substitution. Why is substitution not such a great way, or not such a great method here? Kind of the same reason as it was for the graphing. I erased the work here, but I'll put this back in a slope-intercept form. It was y equals negative 6/5 x plus 22/5. You know, the goal of substitution is to get one of the variables by itself, right? Which we've done here. Which means we're going to have to take this negative 6/5 x plus 22/5 and substitute it in for the y variable in the other equation. And so you're left solving 6x plus 4 times negative 6/5 x plus 22/5. My brain hurts just writing it. That's going to be horrible, right? Substitution is not a very clean method either, okay? So when you have coefficients in front of all of your variables, like we do here, 6x plus 5y, 6x, and 4y, elimination is the way to go. Because what elimination has us do is we literally eliminate one of the variables from the system. And if we eliminate one of the variables from the system, how many variables do we have left? Just one. We like when there's one variable to solve for. Okay? And the key to elimination is to match up the coefficients for either x or y. In this case, you've got a 6x in the top equation and a 6x in the bottom equation. Because of that, we can combine these equations by addition or subtraction with the goal of eliminating the x variable. Which means, what operation, addition or subtraction, turns a positive 6 and a positive 6 into 0? Subtraction. And so that's exactly what we're going to do here. We are going to subtract these equations, and we can do this because we've got the like coefficients here, and 6x minus 6x equals 0x, which I like to call ox, just because it looks like the word ox and it's kind of catchy. When I say, remember ox and oi? Okay, ox and oi is the process of eliminating either x to get 0x, because it looks like the word ox, or if we had eliminated y, which we'll do in the next one, then we get 0y, which kind of looks like oi. Okay, so when you hear me say ox and oi, I'm referring to this elimination method here. Okay, 6x minus 6x is 0. What's 5y minus 4y? 1y, which we can write it either as just y or 1y, doesn't make a difference. But then 22 minus 20 is 2. Essentially what we have here, since 0x is gone, it's eliminated, equals 0, we're left with y equals 2. How fun was that? No distribution, no combining like terms. All we're doing is adding and subtracting here. Okay? Yeah?
How do you know when to add or subtract?
It's the operation that gets these two terms to equal 0. Like if you thought of this, do I add 6x and 6x to get 0? No, that'd be 12x. 6x minus 6x equals 0. That's why you subtract. Okay? And now that we've solved for one variable, how do we get the other one?
You plug y in?
Yeah. Does it matter which equation it gets plugged into?
No.
It does not. The beauty of it, right? We'll go to the top one just because. So 6x plus 5 times 2 equals 22. 6x plus 10 equals 22. Subtract 10 from both sides. 6x will equal 12. Divide both sides by 6, and x equals 2. Okay. Initial questions or comments after seeing your very first one, Kylie?
How do you, like, if you did that 5y minus 4y, would that be 1y?
It is. And when a coefficient of 1, we have the option to write it or not write it. 1y is the same as just y by itself. Okay? Because you have a y, a means 1 of something, right? So whether you write the 1 or not doesn't really make a difference. Okay? Other questions, comments? All right. Yeah.
Where'd you get 12?
12. I subtracted 10 from both sides here. I've got a 2-step equation here. I subtracted 10 to solve for x. 10 minus 10 cancels out. 22 minus 10, 12. Anything else? Okay. What do you think? Pretty nifty? Certainly less work than substitution, right? Let's look at the next one there. Negative 5x plus 12y equals 90, and 7x plus 3y equals negative 27. As it's written, negative 5 and 7 aren't the same. 12 and 3 aren't the same. So we can't jump straight into the subtraction like we were able to here. There's one step we have to do first. We have to either make the 5 and 7 to be the same, or we make the 12 and 3 to be the same. And you're looking for least common multiple here. What's the least common multiple of 5 and 7? What's the first number that 5 and 7 both go into? 35. So we could turn this into a 35 by multiplying the entire equation by 7. We then have to multiply this entire equation by 5 to get the x of that to be 35 as well. Or, what's the least common multiple between 12 and 3? 12. Okay? 3 goes into 12 evenly, right? So it's going to be much simpler for us only to multiply this bottom equation by 4 so that we can get the y coefficients to match up. Okay? Because 3 times 4 equals 12, we're going to multiply the bottom equation by 4, which means our top equation doesn't change. It's still negative 5x plus 12y equals 90. In our bottom equation, everything gets multiplied by 4. The 7x will become a 28x. The 3y becomes a 12y, which is what we wanted, right? We match up those coefficients. That was the goal here. And then our negative 27 times 4 is a negative 108. Okay? And now that we have first of all, any questions on where I got the 4, why I did what I did? Yeah. Where I got the 4. So I looked at my 2 sets of coefficients. Negative 5 and 7, those aren't very friendly numbers. Okay? They don't go into each other. 12 and 3, though, if I multiply 3 by 4, I get 12. And the reason why I want that is because once I get one of these pairs of coefficients to match up, I can then eliminate one of the variables by addition or subtraction. But I can't do that unless one of them match. So the reason why I picked 4 was because 3 times 4 is what gets me to 12. Okay? Anyone else? Okay. Now that I'm here, what operation am I going to be doing to these equations to get 12y and 12y to be 0y? Adding 12y and 12y or subtracting? Subtracting again. Okay? 12y minus 12y equals 0y, or oi. Right? They cancel out. And so that leaves me with just my x variable to solve for now. Negative 5x minus 28x gives me,
Negative 33.
well done, negative 33x. And there's my oi, which is just 0, so write it, don't write it, doesn't really make a difference. And here's where it can get a little bit tricky. This last subtraction here, it's not 90 minus 108. It's 90 minus negative 108. You have to go back to that subtraction sign every time you subtract when combining these equations. So it's 90 minus negative 8. And what does 90 minus negative 108 actually mean? Plus, right? Subtracting a negative means you're actually adding. So you got to be careful here. It doesn't happen here because negative 5 minus 28, look at the difference. Negative 5 minus 28, those signs aren't right next to each other. Here they are. When they're right next to each other, it actually turns into 90 plus 108. Okay? So, negative 33x plus oi equals 198, or since that oi is just 0, negative 33x equals 198. And now I have a one-step equation to solve. Divide both sides by negative 33. And x equals negative 6. That looks right. Okay? We're not done yet, so let's solve for y. But I think we've done the hard part here. Okay? Questions on this? Yeah?
Can you just say 0y?
I could, but oi is so much more catchy. Ox and oi. Okay? Just let it become a thing. You know? Other questions? Okay. Now to solve for y, we can pick either equation to go from here. I'm going to erase my work over on the side so that we can use this space. Which equation do you want to go with here? And we actually have 4 to choose from, right? We can go to our original 2, or, well, 3, because we didn't change the first one. Our original top one, our original bottom one, or our new one, after multiplying by 4. Annie, what do you want to do?
First one.
The first top one?
Yeah.
Very well. So negative 5x plus 12y equals 90. I'll write it over here. We've solved for x. X is negative 6, so this becomes negative 5 times negative 6 plus 12y equals 90. This gives us positive 30. And I'll subtract 30 from both sides to cancel it out. 12y equals 60. Divide by 12, and y is going to equal 5. Okay? But it all starts with getting those coefficients to be the same. Okay? Getting those coefficients to be the same. Either x or y. Doesn't make a difference. Okay? So, the last one. Looking at 4 and negative 10. Are they the same? No. Negative 4, look at the y now. Negative 4 and positive 3. Are they the same? No. Ugh. Okay. Does 4 go into 10 evenly? No. Does 3 go into 4 evenly? No. So it's not like the first one where we already had them matching up for us, the 6x and the 6x there. It's not like the second one where we only had to multiply the bottom equation to make it match up with the 12. This one, we've got to multiply both equations. Okay? So, Amanda, since it's your birthday, would you like to match up the x coefficients or the y coefficients? Would you like to get ox or get oi? Ox. Okay. So matching up those x coefficients, what's the least common multiple of 4 and 10? What's the first number that 4 and 10 can both go into, Kate? 20. Right? So our goal here is to make these coefficients 20. The sign doesn't matter here, and we'll find out why shortly. The fact that this will be a positive and that'll be a negative doesn't make a difference. But what do we have to multiply that top equation by to make a 4x and a 20x? Times 5. Okay? So we do that, and our top equation becomes 20x minus 20y equals negative 100. Just remember, you have to multiply everything in the equation by whatever the factor is that you're using there. And remember, our goal here was to make these x's the same. So what am I going to have to multiply the bottom equation by to make that 10x into a 20x? 2. So now that gives me negative 20x. 3y times 2 is a positive 6y. And negative 20 times 2 is a negative 40. Stop me if you've got questions. Because this is probably the most involved one you'll need to do, where you have to multiply both equations by something. Okay.
How'd you get 40 or negative 46?
Take this 2. It essentially gets distributed into everything in the equation. So I got the negative 20 from 2 times negative 10. 2 times 3y is a 6y, and 2 times negative 20 is a negative 40. I picked 2 because our goal was to get these x coefficients to be the same. And so starting out as a 4 and a 10, the least common multiple of 4 and 10 is 20. So I multiply the top equation by 5 to turn that 4x into a 20x, which means I multiply the bottom equation by 2 to turn that negative 10x into a negative 20x. Okay? Yeah?
So can you just choose whatever number you want then?
Yes. We could have gone to 40, because both 4 and 10 go to 40. We could have gone to 60, could have gone to 80.
They have to be the same.
Just have to be the same.
Only x.
No, you could have done y also. If Amanda had picked oi, then what number would we be going to for the coefficients to y? 12. Okay, we'd multiply the top equation by 3, the bottom equation by 4. You get to pick. Okay? You just have to make those coefficients to x or y the same. Anything else? These are good. Keep them going. Okay. So now I've got this 20x and negative 20x. What operation causes a positive 20 and a negative 20 to cancel out and be 0? Is it 20 minus negative 20 or 20 plus negative 20? Which one of those equals 0? Plus, right? 20 minus negative 20 equals 40. In this case, the first 2 we subtracted. In this case, I need to add, because 20 plus negative 20 is what causes these to cancel out. Okay? So you've got to think about what operation gets me to 0. Then the next one, negative 20y plus 6y. Negative 20 plus 6 is a negative 14. And negative 100 plus negative 40. Jeffrey?
I just have a question.
Yeah.
So, with the negative 20 and then the two 20x's, you're trying to get 0. Right?
Correct.
So what if they're both negative?
If they're both negative, then you would subtract. Because a negative 20 minus negative 20, or the same thing as negative 20 plus 20, that'll get you to 0. The basic rule of thumb is if your signs are the same, if they're both positive, or if they were both negative, you subtract. If they're different signs, like we have here, you always add. Okay? Anyway, what's negative 100 plus negative 40? Negative 100 plus negative 40. Negative 100 plus negative 40. What does that equal? What? Negative 140. Okay? We're starting negative and adding a negative is the same as subtraction. So we're really taking negative 100 minus 40, and that gives us a negative 140. Now we've got a one-step equation to solve. All we got to do is divide by negative 14, and y equals positive 10. And now that we know y, how do we find x? Jack?
What?
Are you really excited to answer this question, or?
Oh, no, I just found my AirPod that I lost last week.
That's fantastic.
Looking for
We're all happy for you. Very, very good. Now that we've found y, you found your AirPod, we found y, how do we find x?
Plug it in.
Plug it in. Does it matter which equation we plug it into?
No.
No, we've got four options here. We have our original set of equations, or we have the new set. If your lucky number is 20, maybe you want to use that one. Doesn't make a difference. Just for consistency, we'll stick with that top equation that we've been using here. So 4x minus 4 times 20 equals negative 20, right? Not 4 times 20, 4 times 10, sorry. 4 times 10, y is 10. Okay? So 4x minus 40, I'm derailing here, folks. 4x minus 40 equals negative 20. Two-step equation to solve, add 40 to both sides. We get 4x equals positive 20. Divide both sides by 4, you get x by itself, and x equals 5. Okay. Now that you've seen three of them and kind of seen all it has to offer, what do you think about elimination? Okay? I mean, it is cleaner than substitution. When you have these coefficients to all four variables, substitution becomes really tricky because you get those fractions to work with. Definitely better than graphing, just for the accuracy piece. I think that the more you work with this, most students kind of gravitate towards this. Maybe because it's called Oxenoid and it catches on. Probably not, but there you have it. I would like us to play the number game tomorrow. And so I am going to give you one question to do. That is all. And it's the example at the top of the page. 2x plus 5y is 1, and 7x minus 8y equals 29. Now, just looking at this, are you going to have to multiply one equation or both equations by something to get the coefficients to match up? Both. Because they're not the same to start with, and 2 doesn't go into 7 evenly, and 5 does not go into 8 evenly. Okay? You can choose whether you want to get x by itself or y by itself. That's your option. Right? But you will need to multiply both equations by something to make that happen. Work must be shown. Without work shown, it'll be marked as incomplete. And it's just this one question that you need to do for homework tomorrow. Questions, comments, concerns, complaints, comments, congratulations, or criticisms?
Congratulations.
Thank you, Johnny. Anybody else? All right. That is how you math. Do the like and the